Hi guys, Mrs. Suya here. I was going to just do a quick video about the box method for those of you who are interested. So box method is used for factoring these more complicated trinomials where the leading term is not 1. So 3, 4, and 5, we already worked them on our notes on the last video. So we do already have answers for them. So let's go ahead and let's just do number 3 and we'll do number 5. All right, so here's how it works. First step for box method is multiplying the first and the last term together. Right? And we get a 6. You know, I think I'm going to just copy this down. 2x squared plus 5x plus 3. So I can do my little box thing up here. It'll help line it out a little better. 6. Okay, so now what we want to do is we go off to the side and we try to find two numbers that multiply to give us 6, add to give us 5. So this is the hard part about box method. If you get a big number here with a lot of factors, it can be a little intimidating. Oops. Okay. Okay, so we have a positive 3 and then we want to get two numbers that add to make a positive 5. So that's a 2 and a 3. All right, so what we do is break this middle term into these two terms right here. 2x and 3x. Okay, and now we just copy our first number term down and our last term down. And we've got 4 terms, so we're going to go place them in our box. First term has to go in this corner box, and last term has to go diagonal to it. And then the two middle terms can go in either one of these boxes. 2x, 3x. All right, and now we just do kind of what I would almost call a fake factoring step. We look horizontally and we say, okay, what could we factor from these two terms? We can factor a 3. From here, we can just factor a 2x. And then we do the same thing vertically. All right, from here, all we can factor is an x. And from here, all we can factor, well, nothing factors out. So we put a 1. We could factor out a 1. All right, and so these numbers right here end up being your factored form, right? So just x plus 1 to x plus 3. Just show, is that what we had, right? We have 2x plus 3 and x plus 1. This process takes longer. Some people feel a little bit safer with this method because it does give you a set of steps you can go through that should work at each time. Okay, let's do the second one. Look, I'm going to turn my paper this way so I have a little bit more space. Okay, so again, if we're going to do box method, let's first deal with this leading negative term, which is awkward. So we are going to take out that negative, which flips all the signs on the inside. And then we just ignore this negative for the rest of the problem. And we just have to remember to put it on our final answer. Okay, so step 1 is to multiply these two numbers together, which is a bit of a nightmare. Let's see, 21 times 12 is 252. And it's negative because that negative was 12. So then the next step becomes what two numbers multiply to make negative 252 add to make negative 4. And you can see that this all of a sudden doesn't become like a very friendly process. Here's where I would start with this, because to sit here and try to go through all the factors of 252 is going to take too long. But you do know one pair of factors is 21 and 12, right? One of them has to be negative. And if I looked at their difference is 9. And so I know that I want to find two numbers whose difference, right, is 4 or a negative 4. Just, you know, if I subtract them, I want to get a 4, not a 9. And so I want two numbers closer together than 21 and 12. And so I'm just going to write the factors of these guys, 2, 6, 3, and 4, and see if I can generate a combination of numbers that are closer together than 21 and 12. So that's 28 and 9, or, yeah, so that is no good. Or 21 and, that's 21 and 12. Okay, so like if I did the 7 and the 2, I get a 14, and the 3 and the 6, I would get an 18. All right, so I'm thinking 14 and 18. Let's see. 14 times 18 is 252. And they would generate a difference of 4. So, box method, not totally friendly when you get very big numbers here, but it's still a method that you could sit around and try to figure out. Okay, so 14b and 18b. And if I want a negative, I'm going to make that negative and this positive. 21b. And 12. Okay, so once you do that, that is to me kind of the hard part. Now we're going to go ahead and do the box part with it. Okay, so we are going to do 21b squared, lift off the squared, and negative 12, 14b minus 18b, okay? And now we are going to factor 4 times. All right, so right here, so here's where the other part that I don't like about box method, and that is, there's a little gimmick you have to remember with the signs. All right, when the number in this box is negative, that's when you factor a negative out. This box has no bearing on it. Okay, so this is going to, let's see, we'll be able to factor out a 6 here, and a 7b here. Okay, and then if we go vertically, it looks like we can get a 3b here. And right here, because this is positive, this is going to factor positive. The negative on that 12 has no bearing on what gets factored out. And let's see, that looks just like a 2. All right, so these end up being my factored binomials. So it should be 7b minus 6 times 3b plus 2. Let's check it with the one that we already factored in class. And look at that, 7b minus 6, 3b plus 2. Okay, so that's it. Good luck if you choose to do box method. Sometimes it does work well. In this case, I think just trial and error would have been a better choice.